So, nochmal einen wunderschönen Nachmittag und willkommen zu unserem Webinar, wo es geht hier um die Packet Visibility, gerade in kritischen Infrastrukturen und in ICS-Systemen. Auch hier ist es sehr, sehr wichtig, dass man eben den Überblick bekommt, was an Paketen läuft. Das Ganze starten wir zusammen mit der Firma Garland. Ross, next slide, please. So, mein Name ist Richard Hellmeier, ich bin der Geschäftsführer der Firma Aqaio. Wir sind der Distributor von oder für Garland, für Deutschland, Österreich und die Schweiz. Mit mir zusammen habe ich den Ross Green, der ist verantwortlich für den Vertrieb in Europa, und den Neil, der Chef der Technik in Europa. Und dafür möchte ich mich sehr bedanken, dass die uns hier unterstützen. Wenn Sie Fragen haben, bitte ich Sie, diese Fragen hier in den Chat zu stellen. Wir werden sie dann am Ende des Vortrages und der Demo werden wir sie dann beantworten. Okay, so that's from my side, Ross. Maybe you can take over.
Thank you, Richard. Good afternoon, everyone. And thank you for the opportunity to present Garland technology to you. Garland Technology are a leader in critical infrastructure visibility solutions for OT space, enterprise, service providers, and government agencies worldwide. Our objective is to make secure network visibility an easy, seamless experience for our customers and our business partners. For over a decade, Garland Technology has worked with OT customers to identify their unique challenges, delivering the industry's most extensive and reliable network tap, data diode, and packet broker solutions. Garland Technology are the supplier of choice for customers across the globe. Critical infrastructures can be found in many vertical market segments. I include here just a sample of some of our customers, many of which I'm sure you will recognize. Like every system that is networked to the internet or where physical access is available, industrial control systems need to be properly secured. With Industry version 4, the importance of a comprehensive security infrastructure becomes even more important. Typical requirements include threat detection, asset management, operational visibility, as well as compliance to standards and government recommendations. Oh, it's gone backwards. There are numerous companies focused on providing security platforms in the OT/IoT space, including industry-leading vendors such as Nozomi Networks, Dragos, Forescout, and many more. Garland Technology has been deployed with all of these vendors and have been solidifying these relationships over the past few years as technology alliance partners. Together, we all share the same goal of securing and monitoring the ICS infrastructure. A core challenge in deploying security and monitoring solutions into an ICS network is data visibility. These tools need packet level visibility. I'm sure you have all heard the common network refrain, you cannot secure what you cannot see. And it's true, these tools can only perform with the data they can see. And many times visibility blind spots hide threats and anomalies. We sometimes see customers take the packet level visibility component of a security deployment for granted. They might have even identified their security tool vendor and are ready to deploy, or on some occasions they even start deployment, but then they discover that they cannot actually obtain the essential 100% visibility. In the ICS world, where speeds can be anywhere between 10 meg and 1 gig, and even on occasion 10 gig these days, and systems might still be running XP, there are often huge architecture challenges to overcome. Customers sometimes consider relying on legacy switch spam ports for the visibility, and then only later realize that these aren't secure. Depending on the switch age or switch architecture, they're not reliable, or on some occasions, not even physically available. We often see different media types and speeds to the tools they wish to connect. On many occasions, networks have extended over time with no or limited documentation, and it's during a survey or the actual installation that new segments or media types and speeds are identified. Some networks are extremely complex, and there is a need to consolidate and then optimize traffic before passing to the tools. Often there is a need for unidirection or air-gapped connectivity and monitoring. Garland Technology have developed the most expansive portfolio of taps and packet brokers specifically focused for providing the necessary visibility foundation to solve these unique challenges encountered in the OT sector. I'm going to now hand over to my colleague Neil Wilkins, who will take you through some of our products and also some use cases.
Neil, you're still on mute.
And we still can't hear you, Neil.
There we go. Thank you.
Oh, okay.
It just popped up to say I'm muted. Thank you. Thanks, Ross. If we look at it, various different scenarios, Ross has just mentioned that Garland have a very, very vast and extensive range of taps. And we do. There's probably 90 to 100 different flavors of taps inside there. But I think what we probably should look at is understand the different modes that taps are. So from our perspective, all our taps are both portable and modular. They are a combination of passive and active. So we have both passive copper and passive fiber. There is fail-safe on the network ports, which is incredibly important. And in a lot of instances, some of our taps have data diode functionality. And one of the things that Ross was mentioning earlier on is we need the data to be bidirectional. And that is the reason we have data diode series of taps inside our product portfolio to stop that traffic ingressing back into your network. So taps themselves have effectively 4 different modes. Breakout is the traditional mode and the traditional way taps are used, where the data from your 2 devices, your switch to the router in this diagram, and your reverse data router back to switch, is sent out of both your C and D port, so you are on a totally out-of-band network. In the OT environment, we find that taps are often used in an aggregation mode, where the data, again, the A and B, the switch to router, whatever you like to be, that way round, and the converse, is sent out and aggregated both down the C and D port. And that is sent down both of those ports, because we're often looking at 100 meg networks being brought up to 1 gig networks, that side of things. And then the third mode is regeneration. Sometimes and often we call it ourselves the spam mode, where we take that spam port from a switch, we use a data diode tap, and we regenerate that data down to maybe up to 5 different ports outwards from 5 different devices. And the third mode is the bypass mode, which is then for inline, where a heartbeat is checking the inline device, ensuring it's there, and then making the connection back if that device disappears. Oops, 2 clicks together. Oh well. So one of the main things that we look at with taps, and we often hide that as a vendor, we would like you to have ports everywhere. You know, we would like you to have a tap on every link. In the real world, that is not possible, and people do use a combination of spam ports and a combination of tapping inside of those links. Now, one of the things that we really ought to think about, and specifically more than anything else in the OT environment, the switches in those environments tend to be quite old switches and are repurposed for the environment we want them to be in, which is fine. Some of those don't have a spam port, and to have pure visibility of everything, you do need to be tapping. But more important is what we mentioned earlier on. We want our data to be bi-directional. Now, a spam port will allow you to put that data back into your network again. So you do have that opportunity to ingress your traffic back in. And that's the reason we have data diode taps. You can build data diodes yourself and you can do that functionality, but the tap is a much more reliable way of doing it, and is on a completely different cost curve. So we can ensure that that data does not come back into your OT environment. What is going on? Okay, so the next side of things with taps is frequently we use them in this environment for media conversion. So in our range of taps, ironically one that I was asked some details on yesterday, which is quite a common tap, we can still go from 100 base FX to copper. We can change those features back around so you can monitor. I may be wrong, but I still think we are the only tap vendor, or very few actually, that can still tap into 100 base FX market. Now, the one thing about this is that unlike media converters, which you can do, we have that full duplex visibility inside a tap. We have the fail-safe technology, so we recognize power outages and automatically reconnect the link. Now, in a critical information, we're looking at something like 6 to 8 milliseconds, something like that, and the link will be redone, you're off and you're away. So we're reducing any of the impact on your operations, plus giving that a monitoring port if you require it from a further expansion perspective. The next side of things is when we look at our OT infrastructures, they are significantly old in their implementation. They're there, they work, they run forever and a day. So we do find that we have a lot of 10 meg links and we have a lot of 100 meg links. So we can do this link speed. We can, as we mentioned earlier on with aggregation taps, bringing them the size up, and we can link up to a higher speed network. And then from that higher speed to the 1 gig, that may be where you're monitoring things. By default, all our taps are auto negotiation. And they're all auto negotiation, so they automatically sync to the correct speed that you want them, well, that you think they should be, both on your link and your network side. I would say to you, change that. In any network, I would never use auto negotiation, and I would always dictate the speed and tell the network what I want to be. That's my preference, and that's the way I prefer to do things, but that is, I think, the right way. However, in demand, we have auto negotiation by default on all of our port speeds. So the next side of things is we do want that traffic to be unidirectional. We don't want that traffic to ingress back into your network. So we do have a series of taps that have a data diode inside them. And that way we can all ensure that there is no data inputted back into the network. The other side of things though, our taps also have data diode functionality. So what we don't do is we do not connect the transmit port back from the tap back into the device. So there is physically no way that our taps can ingress data back into your network. And our range of taps is very, very extensive, from 10 meg to, well, we do have 100 gig taps as well, but in this environment, we don't tend to be using them. We always be on that 10 meg to 1 gig. And our taps have the capabilities to be used in multiple modes: breakout, span, aggregation, and I'll show you some of that in a little bit later on. We build taps specifically for environments. So at this present moment, we have our standard range of taps. We also have taps that we have built for the OT environment. We have taps that can be DIN rail mounted. We have them that have Mighty Mouse connectors. And we also have power lock connectors for our active taps as well, so that they are shaken to bits and the power is still there. We run on extreme temperature variations as well. So we run on extreme temperature variations and we cycle more frequently. So we look at -40 to +85, and we do more cycles than are normally required inside that temperature side of things. The nuts that we will build specific taps though for a requirement. So if a customer has a specific tap for a requirement for a specific tap, we will build for that. So we have build taps for the US military, for the UK military, and we have some taps in some strange places like Humvees and other vehicles. We're currently building a whole range of products for the transport industry, specifically for the rail industry. And we're building a whole sequence of taps now specifically for the rail industry, which have different extremes of temperature in them. We're also building packet brokers for that environment as well, that have a completely different connector on them. They have different requirements in temperature, as in the temperature ranges. And as you can imagine, if they're in the engine compartment of an electric train, they are subject to no end of vibrations and extremes of temperature. But that is another market that we are completely looking at as we move into all of the requirements that Ross said earlier of this industrial methods. In terms of aggregation, you can simply put a tap into a network, very, very simply, connect between your two devices, and then aggregate that data out. And that allows you to streamline the number of monitoring tools that you will use, gives you 100% visibility of what is going on in that network. And that's the important thing. You need that visibility wherever you are. And that tends to be trying to understand where the flow of your traffic is. Just recently, Ross and I have been discussing with somebody, and that was the first question we asked: where's your traffic flow? And the answer was, we have absolutely no idea, but we need to start understanding where the flow is in this very, very harsh environment that we're under. So this box here that you'll see here in this picture is one of the boxes that we use very, very frequently in an OT environment. This is a half U box that has two different modes, or effectively 2 different chassis. It can be 4 taps, and those ports can be from 10 to 1 gig, or it can be in a 4 or 8 devices, I'm going to say. So there's 8 ports, either 4 taps, or the other variant of it is 8 devices, which on here is put as switches. Frequently in a manufacturing environment, you can replace the word switch with a PLC or some sort of device there. Then we bring that into it, and then you'll notice where it says IDS, there is an SFP cage there, and we can run that out and aggregate those taps up from those SFPs in whatever media you want, single mode, multi-mode, or copper at 1 gig between them. So those are half-U units that we use very extensively in multiple different roads. So we'll often find that one of these is put in a cabinet somewhere, and the number of PLCs or a number of tap links are inside that cabinet, and we bring that back to one location. We can also join the 2 together, as we've shown here, in a plate on a 1U, because this is a half-U rack. 1U together, bring them back in, link them back, and then again bring that data back up. And it's a very, very cost effective, because it's a very low cost box, this, to bring in either 8 devices or 4 tap links in there somewhere. And as you can see here, I've shown it again that we either bring those 8 links out maybe to 8 taps, and we'll bring those 8 taps out into whatever you want those links to be, from switches, maybe even aggregate them up again and aggregate back into this box, and then 1 or 2 monitoring areas. So from a very simple low end side of things, we can do this. One of the other things that we have with a water board is they use this in one place, the SFP cage. We have a USB, and we have the USB tap that will run at 10 gig actually, as a 1 and a 10 gig tap. And we link that link out to the USB to give a remote distance, and they monitor remotely, just coming in remotely via their USB ports. The next device, earlier on I mentioned that our taps can be portable or modular. A portable tap can be DIN mounted, or it can be rack mounted. We strip the casing off that and put it down as a modular tap. The functionality is exactly the same. So I can now take one of those taps, or a selection of those taps, put them in a managed chassis, which gives me the option of greater manageability, because they're all seen as one entity. And then I can aggregate them, I can filter the traffic, and I can bring that across the box to a single monitoring port. Again, often we use this, as I'll show you a little bit later, as an edge device to bring into some further form of aggregator, because what I've effectively done in here, in a 2U format, is brought in no end of small aggregation devices back to a single monitoring station and a single place of monitoring. And this really shows it how we actually use this quite frequently in things like substations and places like substations. This rack that I showed you at the top comes in 1 and 2U, and at the bottom we bring that into some sort of aggregation device. And we often tap those links, pull it down at a lower speed, and then aggregate them all across to a higher speed device somewhere. And we can do that, and we do that at the 1U and 4 taps, or the 2U and 12 taps. And we have a common management and look and feel across our products to make it. Our philosophy is that these are things that you put in place. You want to make them as simple and easy to use as you possibly can, and you leave them alone. So in some of the older, very simple portable taps, they are just a few dip switches, you set them up and you walk away from it. On the later taps, they are all managed by the same common managed system across our range. This actually is a very, very small breakdown of a solution that we have with a electricity generating power station. So each one of these locations you could think of as being some form of substation, sub-driving somewhere. So we tend to have the tapped links in this 1U chassis that we can manage. And we have our data diode that taps with the span links in there as well. So we bring them in with the data diode taps and we're bringing the span ports in. We then bring that back and aggregate it, usually with one of our lower end aggregators because of the speed and everything else. And then we bring that back to a central location. And normally the central location, although it says there is GRE tunnels, I've noticed in the last year to 15 months, most people now use a VXLAN tunnel rather than the GRE. Doesn't worry me either way, whether I use a GRE or a VXLAN, the packet brokers can support it. Then typically what we do is we normally strip the header off before it goes to the intrusion detection system. And quite frequently people use different VXLAN IDs for the different location. So sometimes they leave them on, bring them back and use a different VXLAN ID for a different location so they can see where it's going. Other times they move it off. But it's a very, very common way of we bring things back, tunnel them in, and in various places, if necessary, you wouldn't with an IDS. We can manipulate that traffic if there was different filtering systems and different requirements down there. Okay, so as we move further forward and we move onwards, this is a fairly simple, although it says power, water and wastewater, this is the same wherever we go really, to be perfectly honest. And it's around about where do you think and where do you look at where you're going to put this visibility. From a Garland perspective, that is all we're about. All we're about is enabling you to see the packet wherever it is inside your network. And if because that is the only single point of truth of anywhere. And with that in effect, we can control and we can't control, we can monitor in various different places. And frequently what we find is that people look at it and decide what level of granularity you want. So we can come from your bay control units, your PLCs, or whatever you'd like to call them, and we can tap in here. And we can tap in from that bottom link from those control units. And there we can see what's going on before it moves up the system. In most of the environments that we work in nowadays, the Ethernet side of things is a ring. And invariably we come off that ring, usually possibly with a span port, and we use a data diode tap there from that span port as well. And sometimes we also come into the ring as well. So we can tap into that ring and look at it that way round. And then we bring it up to the higher level in your control plane. And in the control plane, again, we'll look at where we're going to tap or where you think you need to tap inside that control plane. Some people work from the base upwards and other people work from the top down. Because one of the things that we have noticed in the last probably, I've seen it more this last year, is people are kind of like wondering where these problems are coming. And it's that OT, IT overlap between the two and understand where it is. So some people think, I have the budget from the IT side of things, so I'll tap in that way and start to work down. Other people look at it and think, where would I tap the other way and look back up? That's your choice. But at the end of the day, we can come into all of those systems. And whilst I've drawn that as 3 taps there coming into those bay control units, it probably would be one of that black box, and I can come into probably 8 of those control units and link them up from somewhere like that. Now, what we then do is that we then we take those taps of wherever we've got, and it could be I could bring that top ring and I could come back in there, and we bring it into some form of network packet broker. And we have ranges of packet brokers that we are used more frequently in the OT environment. So whilst this one here is drawn and it looks like a 1U rack size, the one we typically use is the one I'll show later, which is a half U. So the half U rack size box, I can rack that, and I'll probably be able to rack these taps with it. So in terms of space, I can put those taps and maybe that packet broker in the same place, or a combination of both inside a rack mounted environment. So I bring those all in, and then I have whatever form of monitoring system I want on it. And the packet broker will allow me to present that data to those monitoring systems on how you decide there to be. Invariably in an OT environment, we don't change that data at all. We don't do hardly any filtering. The best we probably do is done some form of VLAN tag. Frequently we're asked for a tag so that I can have an idea of which one of these control units the data's coming from. So if I look at things like a car industry, paint shops in a car industry, they're very, diversely spread around large areas, and then we'd probably have a box in a cabinet somewhere, linking it back, and they come back with various different racks to a packet broker, and then whatever monitoring you want behind it. And now, so really it's the same concept now. It depends on where you are. Now, in terms of the levels we have here, this is back to something that I was saying earlier on, really. At the very lowest level, at level 1, we have the PLCs, the RTUs, and we tap in there. And we tap into the flow of data coming up. And then likewise, when they come into your SCADA network, so when they come into the center in the SCADA network, looking at where you need to think of the flow of your data and come around. Now, whilst this looks like a lot of taps, in some instances, if you know where your flow of data is going, within your budget, you can do this in 1 or 2 taps. It doesn't have to be something massive, and then you can start to eliminate parts of your network afterwards. And at level 3, we can then sort of tap into their operations. So here I can see from the base upwards, I can see what's coming into my control units, and I can see what is coming down as well, and what is coming across from my IT environment back down again. And this is a solution that, although it says oil and gas here now, with a, I think they're one of the largest car companies in the world I've just been working with. And their problem is they're trying to understand where their problems are, whether it's coming from the IT down or whether it's coming from the OT up. But they're severely, extremely worried about their supply chain and what is happening in their supply chain. So in a very small area, we have started to tap into different parts of their network. And by doing that, we can start to eliminate things and put things down process by process afterwards. Because not only is it this baseline infrastructure at the bottom, and we kind of know we can do that, but it's the bit that's coming in from the IT environment around. And sometimes that is just a simple 1 or 2 taps, and we can start to analyze and what's coming through. Now, what I wanted to show here really was the combination of how we're looking at this with the breakout of a tap. So in here, what I'm looking at now is I'm looking at this network here and expanding really this tap onwards. Now, in this instance, your A and B is being presented as 2 ports. So what most people forget is their data as it's shown here from their router to switch comes out of the C port. But don't forget, you have a full duplex link. So you have your return data switch to router, which is now coming out of your D port. When you bring that back to aggregate it, that is 2 ports, because your aggregator needs to see those 2 ports together to bring it back to a single flow. And that is very, very frequently forgotten by people. And we often get these comments when where people have connected these things up and say, oh, you see half my traffic because you haven't connected the other port across. So what I was just trying to show there is we could tap in and we could do different variations there. I could make that an aggregated tap and take it all out the C port or all out the D port. It makes no odds to me along the way. And the packet broker sits above and links things around. Very, very importantly is data diode taps. What you're wanting to see is you are actually wanting to see data only in the one direction. You never want that data from your control center to come back into your industrial plant. And this is the same whether it will be a physical device or whether it would be a virtual tap. One of the things that people forget, whether it's a virtual tap, is that data can ingress back into your monitoring systems if you're not exceptionally clever with the way that you present that data and the way that you configure your out-of-band network. And hence, that's why we have a data diode tap. The physical data diode tap is there to stop things ingressing back into your network. We've had many people, and I think Richard was one of the people actually on there from Aqaio that said you can build data diodes quite easily. You can't. You can't. There's been a number of people that have tried this, and they find that the functionality of a data diode tap that you get for a few $100 costs them about $15,000 in a true data diode. There's a massive difference, but we do block that data coming back off. We also have data, what we call data diode functionality, so we can limit as well. Some taps have approved a full data diode, some have like a pseudo side of things, but whatever way, we will not ingress that traffic back into where you need it to be. So we will not come out of your manufacturing plant, your industrial plant, or anything will not access back onto that network. So I just want to exit this presentation and move across to a different browser. So what I wanted to do with this was just to show you the simplicity of setting up some of our equipment. So I have 3 devices here. This box that I'm about to log into is effectively the low-end aggregator that we have. The version I have here is a 10-port aggregator, which also has a bypass tap integrated into it. So we use that quite often at the edge of a network between some sort of firewall or something, so we can monitor either side of the firewall and have the aggregation devices. So it's a very simple dashboard for all of our products. So there is no tap connected on this, unfortunately, but you'll see the bypass tap has very limited settings on it. It's not running. There's nothing I can do on this one. But I can tell you now that in terms of heartbeats a second, I'm sending 10. And if I lose 10, so in 1 second, if the firewall or something wasn't there, the bypass tap will take whatever action I'm asking it to do and save. So the packet broker side of things is here. And the packet broker is fairly simple. It's very, very simple to use. This is a half-U box, which would normally give me 10 ports of aggregation. This one is giving me aggregation, as I said, and a tapping. So if I wanted to filter, unlikely in this environment, but I can create a template. So let's easily make a template. We'll just call it web for something else. And I'll call it a test template. Our filters for this are very simple. They're pass all, so everything, pass by something, or deny something. So let's make a filter that will pass it by, and I'm just going to make it anything silly. I'm going to make it by 2 different VLANs. So anything that's passed on VLAN, inner VLAN 20 and outer VLAN 21 will be there. I'll call that VLAN just for something else. There we go. So it's a fairly simple filter, and I'll save it. So now when I come back to my configuration map, I haven't got anything configured at the moment, so I'll create a configuration map. Ports 1, 2, 3, and 4 on this box are associated to the bypass tap. So the data from the bypass tap is already done there. So now I'm going to decide what I'm going to do. So simple. So a fairly normal port, I'm going to have a port 5, port 6, and I'll aggregate those out to port 12. Save it, and that's done. If I wanted to filter, well, there's the filter I've just made, and I'll drag that filter across. So now from port 5 to 6, going out to port 12, it would only send the data on port that came from VLAN 20, inner VLAN, and outer VLAN of 21. If I then went, but all of that data from 5 and 6 is going to go to 12. If I brought in 11, and I bring in 9, so 5, 6, and 9 will go to 11 and 12, but they will both get complete copies of that data. If I wanted to change it, I would change this and make a load balancing group instead. So I'd create a load balancing group, and I'd move whatever those ports were into the load balancing group. So we'll load balance those, and then I've got a policy for them. And I set a policy up, and what do I want the policy to be? How do I want it to create that load balancing policy? Is it on the source address? Is it on the destination address? So it's a very simple aggregator to set. Our thoughts are, you touch this once and you go ahead with it. The next side of things here, you'll see on all our devices, we have the configuration on the side. So if I come across to this one, this is a tap now. So this is actually a tap. So again, this is a tap. I could mount that tap in a bracket with that aggregator. So I could mount 2 of these taps in the bracket, taking up 1 U with that aggregator. Now at the moment, I have it set as a filtering tap. If I change it to an aggregation tap, and I've set it now, I've changed the mode of that tap. Instantly, you'll start to see that some of the things are changing on it. My mode has been set to aggregate, and you'll notice at the top, one of my settings disappeared because it's no longer acting as a packet broker. So the data is going to be aggregated from port 1 and 2 out of ports 3 and 4. So if I come back to filter again, you'll notice that it had all the modes for the tap up there. So there's all the different modes it can be in: bypass, span, breakout, etc. If I come back to now has my packet broker functionality back again, it's exactly the same. It's exactly the same. So if I create a config map, I can create filters, filter templates, exactly as I did before, create a config map. Well, what am I going to do this time? Ports 1 and 2 aggregated to port 4. I didn't create any filters. I didn't make a filter. So it's now performing as a small packet broker as well. So when I showed you those devices put together, this is how we set them up and link them down in a line. The system will look exactly the same, and you'll see you'll get this system info and this very similar setting down on all of the side of these things. But there we go, back to the dashboard, and I can set it to be a bypass tap. Change it to a bypass tap, and now I've got all my bypass modes and everything, and I've got all the bypass up here. So now I've got all the settings as I had on that aggregator earlier of a bypass tap. Back to systems, and I can't remember even where I did it now. There we go. We'll put it back to aggregate and we'll get everything back. So that's our general interface that runs on our Garland aggregators and our Garland taps. So if I just log out before it times me out. If I come back to our higher end aggregators, the side of things I wanted to show there is I wanted to show that although this is one of the mid-range of the Garland aggregators, so this is our advanced features aggregator that does a lot. It does a tremendous a lot, you know, packet slicing, time stamping, 9 layers of MPLS labels and filters. It does a tremendous amount, this box. If I went back here and came to my interface status, you'll see it's a very similar. All I wanted to show is I'm going to pick the middle here. Speed, auto. We can come all the way down to 10 meg still on this device. So this specific packet broker I can still use at a very, very low end to bring in on this one 40 PLCs if I wanted to, or 38 if I was going to ask about some monitoring ports as well. But I could easily bring in. So you can see on that earlier diagram where I had the concept of substations, I use a very low end one of these and bring in maybe 20 or 30 different tapped links. And then I bring that up to some sort of tunnel out of it. And I create some sort of tunnel. In fact, it's very similar, not quite the same, but if I was to create a tap group table, it's there when I add. And you can see the truncation and time stamping now appears now because it's a higher purpose box. But I had a tap group table. I'll call it something, I don't know. I won't give it an ID, I don't need to. And then I just edit it. I just edit it and then add what I want to do inside there. So it's very, very simple box to do yet again, easy to make. And our idea is you leave these alone and you never touch them ever again. And that tends to be how we use our boxes. And with that, I'd like to hand back, I think, to you, Ross, so that you can take over for the last few slides. If he's still alive. Hello?
Yeah, I'm still alive. Thank you, Neil.
Do you want me to stop sharing or do you just want to take it, Ross?
Let me just take it. And I should have stepped this on. So let's quickly slick through these slides that Neil's already covered. Planning and Organization 0. So just to summarize today's presentation prior to the Q&A session at the end. Firstly, thanks for the demonstration, Neil. I'm sure people appreciate seeing some of the products in a real life environment rather than just on pictures on slides. Garland Technology have significant experience in the critical infrastructure space, and over the past 10 years have developed probably the most comprehensive portfolio of products specifically for this market segment. Our technology expands beyond out-of-band visibility to, as Neil showed, to include monitoring and connection of inline security tools as well as cloud visibility. Our tap-to-tool architecture is designed to operate in any environment and deliver exactly what is required by the security tool. It offers scalability in what we would consider to be the most economical manner. Garland Technology are an innovator and always prepared to consider and build customized products. And Neil mentioned some of the things that we're doing for the railways at the moment. Our engineering and manufacturing are all located in the USA, but we have people located around the world from a sales and marketing perspective. From a business partner perspective, we work closely with our business partners as we do with, for instance, Aqaio in Germany. There's a significant market opportunity for business partners in this particular market sector. We're seeing high growth and high expansion, high uptake in terms of companies that have limited or zero current security in their OT infrastructures, needing to actually adopt some security policies and integrate security technologies. Our products are very much complementary to some of the OT tool vendors such as Nozomi, etc. Our products are high quality products, robust, designed with the OT environment in mind. We have probably the widest product portfolio in this space, and we have a lot of competitive feature advantages. Our pricing is competitive. There's good margin for our business partners. We also offer margin protection through a deal registration system. We have a partner portal, and I'd encourage people to enroll even prior to becoming a partner in our partner portal. Within our partner portal is a wealth of information, case studies. There's an extensive training series of videos and material. However, we work as I said, we work very closely with our business partners, and we provide free training, and we also offer a free technical design service where the likes of Neil will provide our partners with Visio diagrams for their customers and designs. We provide our partners obviously leads, and we're absolutely committed to doing joint marketing activities. Garland Technology and Aqaio, we're here to support you from start to finish and through the lifetime of any installation. So with that, I want to hand back to Richard for any questions. I noticed a question did come through on the chat, which I believe is for Neil. Back to you, Richard.
Okay, thank you. Thank you, Ross, and thank you, Neil. So if there are questions in the please put it in the chat. We have a couple of questions. I start with the first one, and I just read it for everybody. Is it possible to filter defect packets parallel to traffic, probably from MAC-X, to see special traffic and defect traffic in the same data stream? So that's for you, Neil.
Yes, you can. I mean, you most definitely can do that. But what we normally ask, and the great thing is to find out really what the customer wants, and then we'll work backwards. So often people ask us for some really unique filtering and unique ways. So the best thing is to catch a PCAP, send us a PCAP file, and we'll run it through. Tell us what you actually want this to do. We'll run it through a system. We'll run the PCAP through, we'll simulate it, and then we'll give you an output. And we'll give you the output so you can have a look at it and decide, is this really what you want? But I don't see any problem with that. I don't see any problem with that. I think it's a fairly straightforward thing.
Now, a very easy question. What happens if I lose power on one of the passive taps?
No problem at all. The network ports are connected, for want of another word. The network ports are connected. There isn't an issue at all. You'll lose your monitoring, of course, but your network will still be there. Your network will still run.
Okay, maybe the last questions, and the other ones we are going to ask or to answer, sorry, later. So in the use case, you show devices with 4 internal tabs. Does this have a data diode functionality?
That does actually, yeah. That does. But if you go to our website, you'll see an area there, and you can drop down, will tell you exactly what devices have got data diode in them. There's a whole sequence of data diode tabs.
Maybe the last one, because this seems to be a more complicated question. So in the demo network diagram, so I could only see Ethernet switching. The question is, what about MPLS, IP, especially TP?
Well, there's no problem. Again, it depends on what the actual requirement has. So in the advanced features aggregator, I can strip on 9 layers of MPLS header, and I can load balance across 4 different layers of MPLS header. So you can decide what you want to do there. So that would be the aggregator, the last device I showed you. So that would be 9 layers of filtering and 4 layers of load balancing. On some of the other aggregators, it's more like 2 or 3 layers of filtering and maybe 2 or 3 ports of load balancing. So there isn't a problem. You can do about 4,000 levels of different filter, depending on the aggregation device that you use. For MPLS, I would recommend the advanced features though, which is the box I showed here.
Okay, thank you very much. So I think we're running out of time. So vielen Dank fürs Zuhören und vielen Dank für die Fragen. Wir haben noch ein paar, die werden wir jetzt offline dann hinterher beantworten. Bitte kommen Sie auf uns zu, wenn Sie noch Fragen haben. Ich danke, dass alle so zahlreich hier geblieben sind. Es war doch ein trockenes Thema und ich wünsche allen noch einen wunderschönen Nachmittag. Und bis dann. Tschüss. And thank you, Neil and Ross.
Thank you, Richard.